Recording. You are recording. Great. All right, so this is the gINT training session on how to create cross-sections using gINT. As I said before, I am going to upload this manual, which Callan Holmes created for gINT. And this will be uploaded on the Coffee Intranet, so you'll be able to find it, and I'll have all my notes from today too. Yep. All right, so first thing is we have gINT. And I'm going to use an existing file. This was for a project up in Silverdale. And it was for an enormous development. I'll show you the CAD plan. So Zach and Mohit, you guys are familiar with this project. There's tons of information in here. I think there was something like, let's see how many tests there were. I don't know, 150, 200 test points, boreholes down to like 30 meters. The only thing I didn't see in here was CPTs, but we'll cover that another time. So this is a good project to do. This project also had 3 different surfaces, so it's a nightmare. And to do that many cross-sections manually would probably take you the better part of a month. So if you can learn how to do this in gINT, it will save you heaps of time, and it's much, much easier to add new information accurately in gINT. So let's say you draw a cross-section, and then next week they go out and drill another borehole right there, and you're like, I want to add that cross borehole to this section and this section. It's going to be a lot easier to just re-export your cross-section from gINT than to manually go in here, plot it, measure the offset, move it over, and plot it on your cross-section. And when you're done, you can get something like this. So this has all my boreholes at exactly the right elevation, exactly the right GPS coordinate system. It shows the offset, the depth of the hole, the little water symbol, the different material graphics. It puts a little legend down here for the different materials. And this is all done from gINT. I didn't have to put this in CAD at all. The only thing that doesn't work out sometimes is sometimes gINT overlaps the text, and that's when you would import it into CAD and manually correct the minor things. But for all intents and purposes, if you need a cross-section in 5 minutes, this is the best way to do it. So I'm going to walk you guys through that step by step. So step 1 is we're going to create a surface that we can use in gINT. So I'm going to go into a surface file. And these are contours. And if I click on the contours, this is actually a surface. If I go layers, all layers, turn on layers, there's my contours. So these white things are contours. And if I show you, they all have an elevation. Down in the lower left-hand corner, there's your coordinates, your drawing coordinates, and it also has your elevation. So when I hover my mouse here, it shows that that's an elevation of 31 meters. So that proves that it has elevation data. You can also get that from going Properties, clicking on it, Properties, and bam, it has a Z elevation. So once you have your contour file, you're going to create a surface, and you get that by going to the Prospector tab. Prospector. And I can go to Surfaces, and then I'm going to create a new surface, and I will call it Existing Ground Surface. Okay. And now I'm going to add some contours to that surface right there. And I've got, sometimes you'll have other things in your drawing, and I only want to see, I don't really care about all my boreholes at the moment. I just want to see my contours. So I'll click on the contours, and I'll click Isolate. And now the only thing that's showing up is my contour data. So now I can go over here to Contours and go Add. And I usually just leave it all the defaults. Click OK. And now I'm going to highlight all those and click Enter. Again, this is mainly for the benefit of Mohit and Zach. If you don't understand what I'm doing, just cruise. Just know that it can be done. So you get a whole bunch of error messages, ignore those. And then when you go over here, now my existing ground surface should have some contour data. There it is. And remember, I'm on isolate, so I have to unisolate now. Unisolate, there it is. And now it'll show all that stuff. So, and sometimes it usually draws it on the 0 layer, so sometimes you have to thaw all layers, turn on all layers in order to get it to show up. Looks like it's there though. So another thing I can do is I can go to surface properties, just so you can see it. Not that one. Go to edit surface style, and I will make my major contours something so that you can see them, like bright green, and I'll make my minor contours something yellow, and now I can click apply, and bam, you can see that I definitely have a surface there, and it shows all my major and minor contours, and then you can see the boreholes over it. So once you have your surface, the next step is gINT can only read an XML file, I think. And so what you do is you go to your prospector tab again. That's your prospector, the one with the yo-yo up there. And we'll go to your existing ground surface, and you click Export to Land XML. And you want your surface and your existing ground surface. And then you go down here, specify land XML version, and it must be 1.0. gINT is an older program, or it's pretty simple, so you need to go with the simplest one. And then you click OK. It's going to ask you where you want to save it. I'll save it on my desktop. And it should be land XML. Save. Loading, 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 loading.
Are you saving some sort of file that you're going to turn around and dump it into gINT?
Exactly, exactly. So, a lot of these files are ginormous too, so make sure you save often. And I've actually found it really helpful to copy the gINT file onto my desktop. So it's somewhere on my desktop. If it's running off the server, it sometimes freezes the server because you're dealing with so much information. I think the gINT file I have open right now is, let's see how big it is. gINT files, it is 408 megabytes, I think, because it has 3 different surfaces and all that, all those borehole informations, and is absolutely going to crash the server. The server's trying to transport information between wherever you are in Auckland or some other place. So let's see if it's finished. It's probably still loading. No, it's finished. Okay, great. So once you have your surface, the next step is to import it into gINT. So in gINT, there's 2 ways you can do this. It'll either show up like this and you have all your tabs on top, or you can click this little button over here that says Show Navigation Tree View. You click that, and then it shows all the different subgroups along here. I'm more familiar with this, so I'm just going to go here. I think it's under, way over here on the right-hand side. If you click the little arrow until you get to the end, there's the Surfaces tab. So you'll click the Surfaces tab. And I already have 3 surfaces loaded in here. I'll show you how to load a new one. If you want to load a new one, you go up here to New, and we'll call it Existing Ground Surface. And this will tell you what type of line type it is, whether it's solid or dashed or whatever. I'll make it dotted. And then what color you want it to be. I'm going to go with coffee green, 50%. And then it's called a TIN file in here. So you'll go click that. I'll go to my desktop. And there's my XML file that I just created. And I'll click Open. And now I click OK. And I've clicked Store Surfaces and Project File. Again, this makes your gINT file enormous, but it usually works better, and that way you don't have to worry about someone accidentally deleting your surface file and going, oh, I can't find it because somebody deleted it. If it's linked to the file, it'll never get lost. It just makes your file enormous. So, yeah. While we're waiting, does anybody have any questions? Is everybody lost?
I don't have a question, but I wanted to mention that I can't remember if you gave me this or someone else did, but I've got this 5 or 6 page
Handwritten notes?
Handwritten notes. That's
Yep.
like I'm following along as you're doing this with
Yep.
these notes, and it's pretty much boom, boom, boom.
Yep.
Perfect. So once this is over, I can scan that in and send it to everyone in the chat, just so you guys have all got that for reference.
Perfect. And actually what we did is we typed those notes up and we're putting them into Callan's GINT manual. So
Perfect.
we'll send
never
both
mind
of
that.
them because I think we shortened it. We tried to make it shorthand for the GINT manual. So it's
Sure.
verbose, but we'll send both of them, and whichever's easiest to follow, you can use both. So I'll go ahead and send you links to both of them.
Okay, perfect.
Yep.
You're going to say, so that GINT manual is going to come out again soon, is it?
Yeah, I'll just send you a link to it. I think Callan's had enough of GINT for a while, but he's still very knowledgeable, and he showed me where it was saved on the server.
Yep.
And so I'm just updating the latest version that he posted, which is probably November 2013, 2014.
Okay. Awesome.
So I'm just updating it. So that's loading. Boom. There's my GINT file, and it's got all kinds of information. You can see it's green. And I've made my other ones different colors. Final surface is brown, and that's reflected on here. You can see how I have a brown one, a blue one, and a black one. And down here, the black one is the current ground, the blue one is the original, and the red one's the final. So for this particular site, they were cutting down a hillside and terracing it or doing something with it. And this is an exaggerated scale as well. It's 1 to 2,000 horizontal, 1 to 400, so the hill isn't actually that steep. It just looks that steep so that you can stretch things out. All right, so once you have your surfaces loaded, you can always go and edit them. I think it's, so you go to your final surface and click Properties, and let's say I want to change the line type or the color. I'll make it, I don't know, let's find something weird, medium orange, and click OK. Boom, it's an orange now. So now my thing will output orange. When you're done with this, you can click Save and go back to your input. All right, what's next? Creating surfaces in GINT. Step 4, creating cross-sections in GINT. So now I should have all my borehole information uploaded. And in order to create a cross-section, you require 3 things. One is the depth of your borehole. Actually, 4 things. Depth of your borehole, project easting, project northing, and your RL for your borehole. So you need, what elevation did you start drilling it at? So in this case, it would have been about 56 meters. The depth of your borehole, 7 meters. And then your GPS coordinates on your drawing, which you can either get from a GPS or you can get from your drawing. So there's my coordinates right there. And I can copy and paste those into GINT. And it's very, very important that your coordinates for your boreholes match your cross-section. So in the lower left-hand corner, it says 175, 59382. And I should be able to go over here, and it should be relatively similar, 175, 59382. That tells me that it's in New Zealand Transverse Mercator projection. And probably Zach and Poi, you'd probably be the best to talk about if people get confused about that. But there's many different coordinate systems, and if you have things in different coordinate systems, your boreholes will end up in the middle of the ocean or in Australia or somewhere else. So, yep. So first set up your project, put in your borehole information, depth, easting, northing, RL. Once you have all that, then you can go to your output page. And logs is where we usually create just the borehole logs, the A4 pages that we always use in our reports. And then fences is how you actually create the cross-section. So on your Fences tab, we're going to click on the Site Layout button, and this will show us all my contour stuff. Unfortunately, there's a borehole that was in the wrong coordinate system, and so it's plotted way down there. So I'm going to zoom in on where most of my information is. Don't freak out, too. This is all in the notes. So this is just kind of a visual demonstration of what's in the notes. And this shows all my boreholes and all the different cross-sections I've drawn. And they're all plotted pretty close together, which means they're all relatively in the same coordinate system. And I can even see down here that it's in the 175, 5983, 38. So that's good. So now I can do two things. I can either manually draw a cross-section in here. So I can draw from there to there. And when you're done, you click OK. And then you go up to Fence Spec, convert to baseline alignment. And I can call it GINT Magical Alignment. And click OK. And now I have GINT's Magical Alignment. And I can return to output. And I can click Use Alignment. And here's all the different alignments I can use. Alignment is the same as a cross-section. What I want to do is I want to get one exactly matching my CAD plan. So what I do is I go into my CAD drawing, and I want to draw section section, where'd it go? Here we go. I want to draw section AT. CAD's just loading. Oh, okay. The joys of CAD. Anyway, we'll continue without the drawing for a little bit. I want to get coordinates exactly from my drawing. So I could go to my drawing, get the coordinates from it, and then I could plug it straight in. So if you could have exact coordinates, what you can go is you can go back to the Input tab, and on your whole tab, there's a tab called Alignments. And here's Kent's Magical Cross-Section, which I drew by hand, and it has a starting easting northing and an ending easting northing. And then it tells me actually the length of my cross-section, 1,303 meters. So if I knew 2 points on my CAD plan, I could plug those in. In fact, for Christchurch, I recently just did a curved cross-section. So I got maybe 20 points, and I plotted these all in all the way down, and then I got an end section. So those are the two ways you can draw a cross-section. You can either do it manually on the site layout by going Fence Spec, Draw Baseline, draw it. When you're done, you click OK, and then convert baseline to alignment, and then you call it Kent's Magical Cross-Section 2, and then it thinks about it, and I cross my fingers and hope GINT doesn't freeze like CAD just did. Again, this is another reason to save often and work off your desktop because you're dealing with such large files that it's not uncommon for the program to crash multiple times a day. So the more often you save, the better it is, and just requires a lot of patience. So I'll try and open.
Hey, Ken, quick question. That
Yep.
Z1, 2, and 3 in the alignment, have you used
Yep.
those? Is that for roading setouts and things?
Hang on 2 secs. Was it in GINT or in CAD that you saw that?
No, in GINT, it's when you're putting the alignment in manually.
Yeah.
When you've got the...
Yeah. Let's see what happens. Oh, it's doing something. I'll see if it loads back up. It's trying. I'll give it 10 more seconds, and then I'll just close it. The nice thing about GINT is it auto-saves every time you change windows. So I almost never lose information in GINT. It's usually just CAD that I lose information in. So I'm just going to close it. Close. So GINT and task.
Just want to note that it's probably a good thing that these are crashing because it's giving you guys a real legitimate feel for what will happen when you're trying to do this.
Yeah.
Like Kent said, it just takes a bit of patience. It works. It is, in the long run, quicker. But that's just something we have to deal with, unfortunately.
Yeah, I think typically CAD crashes on me 3 times a day for the projects I'm working on.
That said, this project is much bigger than your standard, and bigger projects crash more. Regular projects should not crash 3 times a day. But still, just make sure you guys are in the practice of saving frequently, just in case.
Yep. There it goes. Hooray, I'm free. Okay, so now I can open it again. And it was last saved at 9:25, which was 2 minutes ago. So I didn't lose anything. Sweet. And this was loaded on the desktop, and even though it's an enormous file, it only takes a couple seconds to load once it's on my desktop. If I was trying to do it on the server, it would take about 5 minutes. So I'll go back to alignments, and let's say I don't want my sections anymore, so I can just highlight it and delete rows. And I don't want Kent's magical section either. Delete. Okay, so now I just have my normal cross sections again. So now I'll go to the Output tab. Fences. So now I have an alignment I want to use. We'll use AT. And this is the easiest way, if you want to just see how it looks, is just leave everything blank and do a preview button. And it will plot every single borehole in here on your cross section, which would look like a mess. If you want to do everything within a certain distance of it, you can set a maximum offset of, let's say, 50 meters. 50 meters. I don't want to see any borehole information closer than 50 meters. And then you can just leave all these defaults, and I'll show you what that looks like. So click OK. Just leave all this default. And I'll show you what it looks like. So it's found 7 boreholes within 50 meters of cross-section AT, and it's going to plot them all, and it's going to do the best fit scale. So it's going to exaggerate my horizontal and vertical scale to fit the drawing.
Hey, Kent, are you doing these using the data gel output tool as well?
No, I've never used that tool. I don't know how it works.
Yeah.
So I've heard about it.
It's pretty good if you're doing lots of things repeatedly. So because then you can save your output files, and you could save multiple section outputs, and then rather than having to go back and change everything individually, you can just run the whole lot. So it is actually pretty useful.
That'd be awesome.
Yeah.
I know how to create a script, but I don't know how to use the DAG tool.
Yeah, the output tool is kind of even easier than the script, really.
Awesome.
But it also crashes after it runs normally. But
yeah.
There we go.
So here's all my boreholes. You can see they're floating up in space. That's because I forgot to turn on my sections. So, but you can see that they should all have offsets. So 0 meters. Zoom out. Negative 19 meters. So they're all offset a certain distance. And then down here, it has my material graphic. So this shows only those materials that are used on my borehole, which is nice, or on my cross-section. And then it has all the different units for the different colors down here. So, and this is just on the input tabs. You can go through Callan's GINT manual or ask someone how to input all the colors and stuff. It's just on the geologic units tab, and you can specify what color alluvium it is and the other things like that. So now I'll go back, exit preview, go back to my drawing, and let's say I want my vertical axis to be start at maybe 0 and go up to a maximum of 300. And actually, I'll show you something else first. First, I'll add my my sections, my surfaces, and I want to do these 3. And click OK. And I'm not sure what's going to be the best fit scale, so I'm going to preview it again. I forgot to show you guys the scale. It'll be something quirky like horizontal 1 to 5,631 and vertical 1 to 322. And that usually just gives me a good starting point for my vertical and horizontal axes. Do you guys have any other questions? Anybody completely lost? Silence. Okay. I guess that's a good sign. Almost there. Here we go. All right, so down here, I can see the scale, and it's 1 to 1940 horizontal and 1 to 314 vertical. So that tells me that the best fit is probably going to be 1 to 2000 horizontal and maybe 1 to 400 vertical. That'll be a nice engineering scale. 2000's divided by 400 pretty nicely, so that's what I'm going to do. So I can go here, my scale, everything's divisible by 1,000, so 1, just divide it by 1,000. So if you did 1,000 divided by 1,000, it'd equal 1. So I want my horizontal to be 1 to 2,000, so 2, and it's backwards. My horizontal axis is 1 to 2,000, and my vertical axis is, it's easy. It's just, I want 400. So 400 divided by 1,000 is 0.4. And I'll let it figure out its own minimum and maximum for the vertical and distance. And I'll preview it again. And this time, I'm going to change some of the things in here. I'm going to call it section AT. I'm going to call it, leave it a figure. I'll make it figure 2, because usually my site plan is figure 1. I'm going to draw it by my initials. If you leave the date blank, it uses today's date. If a reviewer has checked it, you can put in the reviewer's name. I'll leave that blank for now. And then most of these things you can leave blank and you can figure out by trial and error. Stick, it usually gives you an indication of what's down here, what it's going to show. I usually just leave it the default. I don't have any CPTs, so I'm not going to worry about those. This is what it shows next to the borehole. I usually want it pretty clean and tidy. I don't want a whole bunch of names next to it, but you can add that stuff. This QC is for CPTs again, and it shows up to 5, 10, 15, 20 MPa, the little squiggles from the cone resistance and friction. And same thing, this is CPTs. Vane shears, these are for your shear vanes. And the little L in front of it shows which side of the borehole it's going to plot on. So it's going to plot on the left-hand side and how far of an offset for. So I'll change that to 2. I want it a little bit closer. If I have SPT N values, it's going to plot those. So I usually don't want these two to be the same. If I have L2 and for both of them, they're going to be overlapping. So I'm actually going to put my SPT values on the right side, and I'll offset it 2. This end plot is a little red dot that shows next to it. I'll put it on the right-hand side as well. Pocket penetrometers, we don't use those, so I could delete those. DCPs, if there are any, I want to see those. I'll stick them on the right-hand side. Maximum value, let's say 20. Hopefully you've broken your DCP by then, you can go home. Consistency, I don't care, I don't want to see that. Rock strength, I don't want to see that in this case. Weathering, I don't want to see that. I do want to see my water levels, so drilling and piezo, and I want to see the end of the borehole. There's all kinds of different options, but those are the ones that we most typically want. And now I'll click OK. It's just going to preview it again. Most of what I've learned in gINT has just been through trial and error. The first time one of the guys I work with here in this office and I did this was about a year and a half ago for a site here in Hamilton. And we had, I think, maybe 10 CPTs on that site, 4 or 5 machine boreholes, and maybe 15 hand augers and DCPs and things like that. And we were trying to create 3 or 4 cross sections, and it was taking forever. So we thought, let's call Callan and figure out how to do it in gINT. The first time we did it, it took us about 2.5 days to learn all this. And now what I'm just showing you is taken less than half an hour once you have all the information input. So in the long run, it saves a lot of time. It just takes, there's a little bit of a learning curve. So don't be daunted if it takes a little while your first time. And Zach and Mohit, you guys will probably appreciate this the most. So now I have all my information. It looks like there weren't, most of these are trial pits, so there's no SBTN values or anything next to them. But it looks like they did have some shear veins, and you can see the piezo levels and the water levels. So that's good. And it looks like
What's the red line?
the red line is, if I go down to the bottom,
Just out of curiosity.
the different surfaces. So the red one's my final surface, the green one's my existing, and the black one's my current. So I think the green one and the black one overlapping. But basically it's telling me the contractor's going to chop down this hill and push some of the dirt out to probably build terrace lots or something. And then it looks like some of my trial pits are floating up in the air. It's just because they're offset up to 20 meters and the ground comes up a little bit as it goes away. And same thing here. So I would not adjust those in CAD. They're accurate. It's where they're supposed to be as long as your GPS points are good. So, yep, so now I'm pretty happy with this. You'll also see that my scale is consistent now. It's 1 to 2000 and 1 to 400. And it even puts a little scale bar in there, which is fantastic. And it does, they're different scale bars. You can see how the horizontal one's different than the vertical one, which is really nice too. Most of the time for what we do, we want a 1-to-1 scale, so it's easy to measure. So I'll show you that next, but a 1-to-1 scale is not going to fit on one page. And so if you just need a quick, I need something in 5 minutes, this is the easiest way to do it. So I'm happy with this, and now I'm going to save my settings so I can write a script. And it saves all the little buttons I clicked. And I can click OK. I'm going to call it section AT. I'll save it to my desktop. Save. I'll make it just export because I don't want it to go straight to the printer once I load it. And I'll click set the library, include all the page properties. And click OK. And it's going to want me, it's telling me I haven't set up anything for the export. So I can also, I think, I can just do a preview. I'll just do a preview this time. So now it's going to save it as a preview. So now if I go back to input, and I go back to output, oh no, it's forgotten all my settings. I have to redo that? No, you don't. If you go up to your script, you can execute script. I can go to my desktop and find that script file, open, and I want it to load the full spec, and click OK. And now it's put in section AT, it's put in all my surfaces, it's remembered my scales, and it's even remembered what I called the drawing and all my settings. So this is probably similar to what the DAG tool does, but I don't know how to use it, so I just use scripts. So you can set one of these for each one, or if I want all my cross-section to be fairly similar, I can just switch to the next one, B1, okay, and then I can write a new script and call it B1, and all my other things are the same. Maybe just the figure number changes. I click OK, and I'll call it section B1. So now I have two different script files I can use for next time. So once you're happy with everything, the next thing is we need to get it into CAD so that we can fine-tune it and draw the stratigraphy and all the fine details that are really hard to do in gINT. So now we're going to go to the export. There's two files that CAD can read. One is the AutoCAD DXF. I'll show you that one first. And we'll call this section AT. And I'll just save it on my desktop. And I'll switch back to, I'll just execute the script for AT. Yep. And I'll click OK. And it's going to change everything the way I want it. And now I'll have to resave that. Section desktop. Yep. Save. Before you export it, you guys remember how this all fits on one page, but if I want to say make my scale equal, so let's go 0.5 by 0.5, 500 to 500, 500 vertical to 500 horizontal. It's not going to fit on one page horizontally. So what I need to do is go up here to Properties, go to Data Frame, and I have to click this button, Expand Frame to Fit Scales for drawings, DXFs, and that only. So I click that, and I click OK, and then I'm going to click Export. And it remembers all my settings, and I click OK. Now it's exporting to the desktop. Again, don't freak out. There's a ton of steps in here. I'm going to write them all down. The notes are pretty explicit, and you can ask Mohit and Zach if you have any questions. It's basically just walking you through step by step what you would do if you saw the notes, and I'm recording this to you so you can go back and see what I've done. But yeah, this has been invaluable. I think the past month I've worked on the Long Bay project, and then there's a bridge project down in Christchurch, and each of those projects had boreholes down to 30 meters and CPT data and all kinds of things. And I was able to do the cross sections in probably about a fifth the time it would have taken me if I'd done it normally in CAD. So you do still have to do all the fine tuning in CAD, but this gets all the information very accurately placed.
Why was it faster in gINT?
Because in CAD, I have to manually measure the distance from the line. I can show you briefly. I'll open the CAD drawing while we're waiting.
Is CAD, do you think, is being outphased then? Or still need CAD to...
You kind of need both. You need both because gINT uses GPS data really efficiently, and CAD is a lot easier to work with as far as making changes. So the nice thing about gINT is it gets everything to the right scale. It gets all your text to the right size and all the DCP squiggles, and it's nice to work with in that respect. But if I want to change the color of something, or if I want to add a little text box that says this is the existing ground surface, it's hard to do stuff like that. So just waiting for CAD to load up. Here's my DXF file here on the desktop. And while we're waiting for CAD to load, I'm going to do let's see, it's coming along. While we're waiting for CAD to load, the other type of file you can export is called a drawing, what's it called? MicroStation, DGN. And this one, the graphics turn out a lot better. So I'll export both of them and show you the difference between the DXF and the DGN. So I'll save this to the desktop. Again, this should be the data frame expanded. Yep. And then for MicroStation DGN, you have to specify what units you're using. And so we are going to be in seed 3D meters. So you click that. This is all in the notes, so again, don't freak out. And then we'll click export. And we'll see how CAD's doing. CAD is still loading. Okay. You guys have any other questions, or are you thoroughly confused yet?
Hey, Kent, I missed the very start, but have you created surfaces down the holes, like say you've got a rock layer, 10 meters deep or whatever, and hollow borehole data? Have you pulled that out and sent it to CAD to create the surfaces?
No, I've just done the ground surface.
From topo maps.
Yes, just from topographic data. It's a lot easier to manually just draw in stuff like that once we get into CAD.
Yep.
So I'll show you. I'm just about to open the CAD files once they finish loading. What I did. I tried to open the Silverdale file, which is a couple hundred megabytes, so I'm not going to do that. I'll just open the DXFs. So what I've done so far is I made sure that, first off, all my borehole information was input correctly, easting, northing, NRL, and depth. And then I went to way down here, this tab called Surfaces. And I imported a couple different surfaces, a current ground surface, a final surface, and the original surface. And they all have different colors and line types so that I can see them on my drawing. It's just taking a second to load. And then once, I think GINT just crashed. Okay. Once I did that, I exported it, and now I have a cross-section I can load. So I'm going to open my DXF and show you guys what that looks like. So it's on my desktop. It's called a DXF. There it is, section AT. And there it is. And it has my trowel pit, the water levels, the colors, and where shear veins were taken. It has shear veins and the different things. The thing you'll notice immediately is it's not to scale. So when I go to measure something, this should be 5 meters long. It's in fact 10. And if I go up here to the scales, between 100 and 150 should be 50 meters. And it is 100 meters, so everything's twice as big. So usually what I do is I draw a line that's maybe 10 meters long. So 10 meters long. And then I highlight my whole drawing and type align. And I'm going to align my 10 to the bottom and my 20 to the top. And then you hit enter, align scales, objects based on alignment points, yes, and it rescales my whole drawing. So now when I click between 50 and 100, it should be 50 meters, perfect. Yep. Next thing I check, everything else is usually okay with DXFs, but you can see how the text looks a bit blocky, a bit quirky, not as clean as our drawings usually are. So I'll show you the difference between a DXF and a DGN. So now I'm going to import my DGN. So I go Insert, Import, Desktop, and I want my MicroStation DGN one. I'll click Open. I usually just leave all this default. It figures out what line type from GINT matches what line type in CAD. And I click OK. And then where's it gone? So you just have to do Zoom Extents. There it is. And you can see the text is much cleaner, much tidier, much easier to read. And I don't have to manually click on the text, change it to whatever I want it to be. It does it for me. So that's why I like MicroStation DGN. The only trouble with MicroStation DGN is it sometimes has quirks like these where, hey, how come my borehole information isn't showing? So I usually just have to highlight it, select Similar, Display Order, Bring to Front. There it is. And I have to do that on each of these. Select Similar, Display Order, Bring to Front, all the way across. But the text and the symbols and everything turns out much tidier and cleaner than on here. And so it's usually easier to work with. The other thing you'll notice is that the water level is missing on the MicroStation DGN. And so what I usually do is I scale my drawing again. So first I make a line that's 10 meters long. That's 10 meters long, so MicroStation DGN is tiny. Align the 10 to there, the 20 to there. Now everything's the right scale, and then I can go in here and click on all my watermarks. So there's one there, there's one there, there's one there, there's one there, there's two there, and that should be it. And then I can, I usually click a base point too that I can recognize, such as the corners, and I'll copy that into this drawing. And then I can highlight my watermarks and copy from that exact corner. And that corner matches exactly that corner. And now you can see that my watermark landed exactly where it was supposed to, right level, right location. That's the easiest way to fix that problem. And same thing, you just gotta right click, select Similar, Display Order, send it back for that, or click your lines, select Similar, Display Order, Bring to Front, and then everything comes in at the right scale. And then in paper space, I can go to, I think I did everything 1 to 500 scale. That's what I want it to be, so 1 to 500. Beautiful. So it has its own title block in here. I usually get rid of this stuff. I usually don't want that stuff because I have my own down below. And then we usually stick our scale bar and paper space in this tab. But some of the symbols and stuff you can leave in the legend. So I will pan this down until it's about like that. And now everything's the right scale. It fits nicely on my drawing. And I just have to make multiple tabs for my drawing now. So I'll go to the next page, and I'll just pan it over. And this is page 2, and page 3, and page 4. And I'd eventually have 4 tabs in paper space. So, and then once I'm in CAD, then I can do the fine tuning. So I can go in here, and I can draw lines between layers, between the bottom of that one and the bottom of this one, and then I can match them and hatch them. And do things like that. once you're in CAD. It's a lot easier to do all the fine-tuning in CAD, but getting the boreholes to the right offset and the right elevation and exactly the right depth on your section, that's what gINT is amazing for. So gINT does all the hard work, all the basic work, and then you do the fine-tuning once you get into CAD. So that's the gist of it. I think I covered just about everything. Does anybody have any other specific questions? I'm just going to open the rest of the time to questions, and I'll upload all my notes. But was there anything else anybody wanted to see, or any other questions you guys had?
Hey, Ken, just quickly wondering, you did the DXF export to the CAD. Is there any better ways of exporting the files out that maybe will have less of those little things, or is that just what we've got at the moment?
I think that's just what we've got at the moment. We talked to Callan about it, and he recommended the DGN, but I don't think he works with CAD as much, and I don't think he realized that it was missing some of those information, and it had quirks. The only other one I saw that I've never worked with was MicroStation DGN, DXF. Where's the DXF? AutoCAD DXF, and there was one other one that was usable. I think those are the only two, the DGN and the DXF, that CAD can read. I'm not sure if there's another one.
Because isn't GINT and CAD owned by the same people? So hopefully will they fix that up?
That'd be nice. That'd be nice. So I have no idea why those quirks. Those are just things that we've observed. That hey, where'd my water level information go? Why isn't it showing up my drawing DGN? But
yeah.
Yeah.
Hey, I should just say, Ken, for anyone else really, if anyone else is doing lots of outputs of borehole logs, say more than 2 or 3 bore logs, it is worth getting the data gel output tool, because we've got it for New Zealand, so it's free. You can just get it added in if you go to IT software, and they can install it, and it saves you a huge amount of time, PDF and files and stuff. So yeah, it's worth looking at if you haven't used it.
Is it somewhere? Is it one of the tools?
It becomes an add-in. Go to add-in next to your right.
Add-ins. Yep.
Yeah.
And
data gel output tool. 2 down.
Yep.
And click on that.
So you just have to get IT to add it for you.
Yep. Yeah, we've got a network license, I think, in New Zealand now. So, and it's like we did 50 bore logs for TG, and they had core photos and sample photos and lots of photos for everything. And it meant, it took half an hour to do what would have otherwise been days with a PDF in. It would have been horrific. So
yeah,
if you're doing 5 or 10 bore logs or more, it's awesome.
Yep. Yeah, so there's a ton of potential for gINT. Callan's manual covers a lot of things. It doesn't cover everything. I think there's even some stuff about DAG. Here it is, DAG tool output tool. And I'll probably show you how to use some of it if you end up getting that. And I'm going to upload my information to this, and then it will be eventually saved on the server. I'll send you guys a link to it. But yeah, those are the basics. This is basically just to show you there is a better, faster way to do cross sections. And it does work. And at the end of it, you can produce stuff. I'll show you a complicated one I did recently. Let's see. These are some drawings I finished last night for Christchurch. So this is for a bridge down there that they're doing near Queenstown. And I exported the original cross-section, I think it's this one. And then I did most of the editing, most of the hatching and fine-tuning in CAD. But you can get the basics, so all the RQD, all that stuff, the offsets, all that stuff I did in gINT. And then I just did all the drawing between stratigraphic layers and all the annotations in CAD. But, yep. So I think that's it. Unless you guys had any other questions, I'll upload my notes at the end of today, and I'll send you guys a link to that and the video I just recorded. And I guess that's it. After that, you're going to have to rely on Mohit and Poi and that, because today is my last day. So.
Awesome. Oh, good luck, Kent, with where you end up.
No worries. No worries. And if you have problems with GINT, for instance, I'm pretty sure there's something wrong with the CPT output in the current template. That's a question for Callan Holmes. And if Callan can't answer it, he can refer you to who can help. So.
Hey, Ken, I got a question here. Most of the time when we receive these site borehole logs, we not always have the easing, northing, and the elevations. And so what you do in that case, how you output it?
So I would go into your CAD file. Try to think of a small one I could open. I'll open the I'll open just the I'll just open the surface file I just had open. So let me find it real quick. I'll show you. So I'll go in here, GINT surfaces, current. Yep. There we go. So I'll go home, layers, thaw layers, turn on layers. Okay, so here's all my boreholes and other information, and I want that. The easiest way to get your elevations and things like that is you can get it individually by copy, 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 and then paste, paste, paste into the appropriate fields in here. Or there's another trick called eat text. It's command EATTEXT. And it's called a data extraction. So I'll make a new one. I'll call it borehole, chords, and elevations. Save it to my desktop. Save. I'll select which objects I want in the drawing. And then I'll just highlight everything. Enter. Next. The only things that I care about are going to be CPTs, hand augers, machine holes, trial pits. Yep. And then the only information that I want to extract is the label, which is the name, borehole 1, CPT label. There should be a trial pit label, trial pit number. And then I want the position X, position Y, position Z. Then it gives you a preview. And so I'll have borehole 2106, position X, position Y, position Z. And then I'll go next, output to an Excel file, and I'll save it on my desktop. Next, finish. And that's how long it takes, and it's already there. And then I can open that Excel file, and I can do a filter and a sort. So I can filter, I can do it sort ascending. So borehole 1, if they're all in order, then I can just copy that big column of stuff and go straight into GINT. And as long as everything here is in the same order as it is in my Excel file, then I can just paste it, 20 of them at one time. And same thing with the RLs. If I don't have an RL for a borehole, what I can do is I can zoom in, and once I've created my surface, I can just hover my mouse and see how it says existing current surface. It has a Z elevation of 54.326. Then I just click on this one on my borehole, and I give it an elevation of 54.236. So I usually find it, type it all in for them, and I do the data extraction and put them all in here and then copy paste it into GINT.
Well, sweet. No, that's another method I knew today now. Yeah, because what I used to do is I used to assign them as a Civil 3D points, and you can project Civil 3D point to follow the surface. And then just output it, because you know how you mentioned in this session before that it's you can't do the projection as in correct offset around the cross section and the long section for the boreholes. Civil 3D you can project objects to the profile. So yeah, that's how I was doing it, because then I just get the point and the label and the offset from Civil 3D, and then I get the fins from GINT. So I was just using GINT as just outputting fences. But yeah, that's really helpful. You told us today that you can get it on a different elevation. So yeah,
Yep.
probably easier that way.
Yep.
Yeah.
Very good.
Cool.
Any other questions? No, that's it. So, yep. So that's the basics. So, just really briefly, real quick. Once you have your borehole information set up, your easting, northing, RL, and your depth of hole, then you can import a surface. Loading. And again, it's good to save most of the stuff on your desktop because otherwise it'll take forever to load. So what I usually do is I work off my desktop with the GINT file, and at the end of the day, I drag and drop it back onto the server. And the next morning, I copy it from the server back to my desktop, back and forth. I almost do no work on the server anymore just because it usually crashes and takes so long. I think it's going to crash again. Once you have your surface loaded, then you can go to the Output, the Fences tab, and export your cross-section. And then you can get it into CAD, and then you can do all your fine-tuning. So that's the gist of it. I'll upload all my notes and this video. And good references from here on out are Zach and Poi and Mohit. All right, thanks for attending, and hope that was helpful.
Thanks a lot.
Yep, no worries.
Thank you.
Yeah. Cheers, Ken.
Thanks, Zach.
Good luck going forward.
Thanks.